afternoon, students.
Good afternoon.
All right, today we're going to look at the revision of what we have done so far, okay? So the first topic that we treated, today's date is what? All right, the first topic we discussed this time is what? It's only vectors. Scalars and what?
Vectors.
Okay, so there are some things you should know under scalars and vectors. So let's go. The first thing you should know is the definition of what? Scalars. And also examples of what?
Scalars.
All right. Definition of scalar quantities. And what again? Examples. Okay. Then we're going to look at definition of vector quantities. And examples. All right.
Yes.
Then the next we're going to look at is what? What is a resultant vector? We're going to solve the calculation at once. What is a resultant vector? What is a resultant vector? Right?
Yes.
Do not forget to state a lot of what? Parallelogram law of vectors, okay? State the parallelogram law of what? Vectors, right? Then what again? Resolution of vectors. Explain the resolution of vectors. Copy fast. Are we done?
Yes.
So if you're asked, what are scalar quantities?
Scalar quantities are those quantities that have
That has what?
magnitude plus no direction.
Okay. So can you give us examples of scalar quantities? Examples of scalar quantities. Speed, yes.
Length, distance.
If you know the answer, you raise your hand. Let's know people that knows what they're saying. Yes, Clifford, are you looking through the notes? Clifford, yes.
Length.
Length, yes.
Volume.
Oyema, yes.
Yes.
Dory.
Mass.
Is a shade, yes. Speed. Okay. Obijiru.
Mass.
Yes.
Pressure.
Doka.
Work.
Okay, so these are the examples of what? Scalar quantities.
quantities.
What if you're asked to state the difference between scalars and vectors? Can you?
Yes.
Include it in that what you just wrote. Difference is just right. State three differences between scalars and vectors. State three differences between scalars and vectors. State three differences between scalars and vectors. Are we there?
Yes, ma'am.
All right. So what are vector quantities?
Vector quantities are those quantities that have both magnitude and direction.
Okay, can you give me an example? Yes.
Momentum.
Yes. Yes. Clifford.
Velocity.
Velocity. Yes. Displacement. Yes. Dorin. Acceleration. Yes. Nima. Moment. Yes. Odogu. Yes. Force. Yes. Temi Goma. Yes. Yes. Tell us what you know. Ndoka. Weight. Yes. Odogu. Electricity is not a vector. Electric field is a vector quantity. Yes. Pulse. Which one is pulse? Impulse. Yes. It's a vector quantity. All right. Can you give me one difference between scalars and vectors? One person. Give me one difference between scalars and vectors. Chukwacha. Scalars. Why? So who will tell me another difference between them? Another difference between them. How are you, uncle? Yes? Yes, Angel.
Vectors are added with geographical methods, while scalars are added with algebraic methods.
By ordinary algebraic method. Yes? Which other example do we have? Which other example do we have? You can use the difference between them to. You can use their examples to state difference between them, right?
Yes.
All right. Any other thing? Any other thing? All right. What is a resultant vector? If you know the answer, raise your hand up. Dorin.
Resultant vector is that vector which has the same effect in magnitude and direction.
The answer is not complete. Yes?
Another vector is that series of which will have the same magnitude and direction. Same effect in magnitude and direction as other vector acting together.
As the original vectors acting together, right? And I told you that we use two methods to find the resultant vector, right?
Yes.
Two methods are what?
Parallelogram.
So who will state the parallelogram law of vectors? One person. Yes, Chukwacha.
The parallelogram of vectors states that when two vectors are put together represented the magnitude and direction of the opposite side of a vector, that the adjacent sides of a parallelogram. The diagonal of the parallelogram is represented by
You try. I guess. Yes, who else? Who else? They are forgotten. Who else? What if it happens to be your number one question and it's compulsory? What are you going to say about it? Okay, try.
Parallelogram law of vectors. Parallelogram of vectors. When two vectors are together, the resultant vector is the line going from the triangle in the diagonal.
All right. I will explain that when I'm solving. Now, can you explain the resolution of vectors? Can someone explain the resolution of vectors? A vector can be resolved into horizontal and vertical what? Components, right? And the horizontal component of the vector is equal to what? V cos what? V cos what?
Theta.
Why the vertical component of the vector is equal to what?
V sin theta.
V sin what?
Theta.
So I'm going to explain the parallelogram law of vectors again. Then we need to solve problems. Do we have our calculators?
Yes.
All right. All right. The parallelogram law of vectors states that what? If two vectors are what? If vectors are what?
acting together.
Okay. They can be represented in magnitude and what?
Direction.
By the what? The diagonal of the parallelogram drawn from the point of intersection of the adjacent side represents what? The resultant vector in magnitude and what? What am I trying to say? If I have two vectors, F1 and what? F2, right? And they are acting at a point called what? Theta. I'm going to complete this triangle to form a parallelogram. Then I'll use the dotted line. You know why I'm using a dotted line?
Yes.
Because this is not the true word diagram, right?
Yes.
Okay. I'll complete it to form a parallelogram, right?
Yes.
Now, this line is parallel to this, right?
Yes.
So this becomes F what? 2. Why this is parallel to this, right?
Yes.
This becomes what?
F1.
Right? I'm going to join the 2 points of intersection and call the line what?
Resultant.
And call the line what?
Resultant.
Resultant what? Vectors. Now we have 2 triangles and we are going to solve with 1. What we are going to do is to bring out 1, right? So bring out this. So this is my R. This is my F2. And this is my what? F1. Now this is what we call an obtuse angle that is greater than 90 degrees but less than what? 180. Remember, at this point, the two vectors are implying as an angle called theta. But here, the angle that we have now is more than theta because theta is less than 90. Okay, so here will be what? 180 minus what? Theta. Right? Now, for us to solve our resultant, we are going to use what? Cosine rule. We are going to use what?
Cosine.
To solve for magnitude. We are going to use sine rule to solve for what? Direction. So for cosine rule, we have r square is equal to what? F1 square plus what?
F2 square.
Minus.
F1.
Have you forgotten? Minus
2F1 F2 cos theta.
cos 180 minus theta. So this is r square is equal to f1 square plus f2 square minus 2f1 f2 cos 180 minus theta. Is that okay?
Yes.
This is using what? Cosine rule to solve for what? Resultant or magnitude. Resultant or what?
Magnitude.
Now for us to solve for direction, we're going to use sine. We're going to use sine. And sine will say that r over sine what? 180 minus theta is equal to what? F1 over sine what? Now look at my alpha, which is my direction, okay? So for sine rule, we are going to say r over the angle facing it is what? 180 minus theta. Sine 180 minus theta, right? Is equal to F1 over sine what?
Alpha.
Is equal to F1 over sine what? Is that clear? All right, put it down. Let's solve problem. Are we done? Are we done? We're going to be solving one example, so we can move to the next one, okay? All right, let's solve one example. Let's solve one example. Are you ready? Yes. Yeah, by next week I will go back to SS1, SS2. Who is that person? I don't want that kind of statement. A body is under, we have started. A body is under the action of two forces. A body is under the action of two forces, 7 Newton and 10 Newton. A body is under the action of two forces, 7 Newton and 10 Newton. Are we there?
Yes.
Find the resultant of the two forces. Chukwucha is sleeping. Find the resultant of the two forces if A, the forces are parallel and act in the same direction. If A, the forces are parallel and act in the same direction. Are we done? Are parallel and act in the same direction. B, the forces are parallel and act in opposite direction. B, the forces are parallel and act in opposite direction. Are we there?
Yes.
C, the two forces are inclined at an angle 60 degrees to each other. The two forces are inclined at an angle of 60 degrees to each other. The two forces are inclined at an angle of 60 degrees to each other. Are we done?
Yes.
So we can solve. The first thing we are going to do is that we should know that the first force is equal to what?
7.
And the second force is equal to what?
10.
Okay? The A part said that the forces are what? Parallel to each other, right?
Yes.
But act in which direction?
The same direction.
So if two vectors are acting in the same direction, what are we going to do? We add, right? So for the A part, for us to get the resultant vector, it becomes what? F1 plus what? F2. Because they're acting in the same direction, right? It's just like this vector, 7 Newton, and this one is what? They are acting in the same direction. So the resultant vector becomes what? 7 plus 7, which will give me. Do we understand? Then the B part, the vectors are acting in opposite what? They're going to subtract from each other, right? By saying that R is equal to the highest minus what? That's F2 minus what?
F1.
Okay. So that is 10 minus 7 to give me what? Is that clear?
Yes.
So the C part say that what? It is inclined at an angle what?
60
To each other. Now for us to get the result, what are we going to do? We are going to use cosine rule, which says that what? R square equals to F1 square plus F2 minus 2F1 F2 plus 180 minus theta. Okay. 2F1 F2 cos 180 minus theta, right? Now, let's solve together. What's my F1? Plus my F2 is what? Minus 2 times 7 times 10, right? Cos what?
180 minus 60.
Is that okay? All right. My 7 square gives me what? 49 plus what?
100.
Okay. Are we following?
Yes.
2 times 7 is what?
40.
14 times 10? 140, right? And this is cos what? To be cos what? So let me add these two to see what I have. R square is equal to 49 plus 100 is what? 149, right? Minus 140, right? Cos 120. Remember, I told you something earlier. When you get to this point, there's a relationship connecting cos 120 and 140. Okay? So don't say 149 minus 140. Do you understand? You must work this one out. It's a multiplication sign here. So when you work it out, you're going to know whether we are adding or we are what? Subtracting. So this is R square is equal to 149 minus 140 multiplied by, right? Plus 120 is what?
minus 0.5.
Minus 0. Okay. This minus will change this minus to what? So R square is equal to plus, what do we have? 140 times 0.5, what do we have? 70, right? So when you add, what do we have? 2, 1. Am I correct? Am I correct?
219, yes.
So I'm going to say R, or R square is equal to 219. The R is equal to root of what?
219.
So divide what? Find the root. What do you have?
14.798.
14 point. Yes. Multiply 0.5 by 140. And for me to get the R, I'll now take roots of both sides. Are we done? So you're going to solve for direction using what? Cosine rule, right? Should I clean the board? You have a few minutes to do that. Now we are done. Okay, Jury, we are not yet done. Please don't have time. Are we done?
Yes.
What would you? Now, the next thing you are going to look at, let us sketch our diagram. Be able to understand what you are doing, okay? I have this. This is 7 Newton, right? Right?
Yes.
6. So for me to form a parallelogram, I'm going to complete it. Right?
Yes.
I join these 2 points to call the line what? And this is equal to 7 Newton, right? We have already gotten our resultant, true or false? So here is 180 minus 60, right? Okay, so can I click? Hey, got it done. Okay, so if I bring it out, you just want to see how I can squeeze it. This is 10 Newton, 7 Newton. This is my what? Alpha, and this is 180 minus what? 60. Using sine rule, what is 180 minus 60? You know how to do it.
Yes.
The side first divided by the sine of the angle facing it, right? 180 minus 60 is facing what? R. So that is R over sine what? 180 minus what? 60, right? Equals to 7 over sine what? And we're looking for alpha, which happens to be our what? Direction. So why are you looking for direction? Because this quantity is a vector what? Quantity. After solving a vector quantity, you must find the what? Direction. It's a must. Even if the examiner did not tell you to find the direction, you must do what? Find the direction. Okay, so let's go. We have R over sine 180 minus 60. Then it's equals to 7 over sine what? Alpha, right? Now, we are looking for our what? Alpha, but we already have R. What's our R?
14.7.
14.798. Okay, divided by 120 is equals to 7 over sine what? We can say cross multiply. We say cross multiply, we have sine alpha is equals to 7 multiplied by what? Sine 120 divided by what? 14.798, right? All right. What is sine 120? 0.866. Okay, so I will say 7 multiplied by 0.8660, okay, divided by 14.798. Can you multiply and divide and tell me what you have? Multiply then divide by the denominator. Tell me what you have. Yes? 0.96, right? Because I'm looking for alpha, I'm going to take the sine inverse of this, right? So this is saying alpha is equal to sine inverse of 0.4096, right? Okay. You don't have to press it. Shift sign. So what's your answer?
24.1797.
24.1797. I can make it be in 2 decimal places. Degrees, which is approximately 24.18 degrees. Is that clear? So this is the direction of the question given to us. Do we understand? All right, so copy. Are we done? Clifford, hope you are not sleeping.
My head is falling down due to gravity.
Gravity is acting on her head. Okay, the next thing we are going to look at is look at vectors acting as right angle, right? Right angle vectors. All right, so what do we do next? We're going to carve out this. You decide to use up or down, right? I'll tell you the difference. Now, if you decide to use this one, what are we going to do? This is my R. This is F2. This is F1, right? Now, this is the right angle. This is what? My direction. So I'm going to use Pythagoras what? Theorem. And it says that what? Hypotenuse square is equal to what? Opposite square plus what? Adjacent square. That is R square is equal to, the opposite to this angle is F1. Is equal to F1 square plus what? F1 square plus what? F2 square. Okay, that is for us to get our what? Resultant or magnitude. Now, for us to get the direction, I know. I mean, how is it like? Is there any day you have like one paper?
Yes.
Which day?
Monday. On Tuesday we have
No noise, no noise.
It's not everybody. It's next week. What are they writing after it?
So if on Friday you don't have anything, can we fix
Can
we listen? Can we listen? Can we listen? I'll be having S3 on Tuesday because we have physics on Wednesday.
We have physics on Monday.
So if we can meet on Friday, what happened?
Having mass and
That day.
as we can meet on Saturday and Sunday because it's that Monday that we write.
All right. Can we proceed?
Yes.
What are example? I see writing. Who is there? Doreen.
So we can use the 6 years time. So we are getting physics.
One more example, then you can end the class, right?
Yes.
Okay, so two vectors, right? Two vectors, 10 Newton and 15 Newton. Two vectors, 10 Newton and 15 Newton, incline at right angle. Two vectors, 10 Newton and 15 Newton, incline at right angle. Are we there? What is the resultant displacement?
What is the resultant?
Incline. What is resultant what? What is the resultant displacement? So how can we solve it? Now, Once you hear right angle, you remember this. It's an angle of 90 degrees, right? The first vector is what? Second one is what? And they are inclined at what? They are inclined at what? Remember, the first thing to complete is, don't go and do this one. You might get the magnitude, but the direction will be incorrect. Okay? You must complete it. You must complete it. And join the 2 points of what? Intersection. This is parallel to this to be what? 10 Newton. And this line becomes my what? Resultant vector. Doreen. Now this is my direction alpha. If I choose to use this part, I have to draw it out for the sake of my direction. This is my alpha, 10 Newton, 15 Newton. This is my alpha, which is my direction, right? So using Pythagoras theorem, r square is equal to f1 square plus f2 square, right? Okay, what's my r? I'm looking for it. R square is equal to 10 square plus what? 15 square. R square is equal to 10 square is what? Plus 225, right? 225. Okay. So if I add, I'm going to have
325.
So can you find the root? Root of this
is 18.02. 0277. 0277.
I can say 03 newtons, right? Now for me to find the direction, I'm going to use sine. No, I'm going to use what? Tan. Okay. That is tan alpha is equal to 10 over what? 15. Tan alpha, can you divide? Divide, what do you have? What do we have?
0.66.
0.666, right?
Yes.
So tan is alpha is equal to tan inverse of 0.666. So what do you have? Shift tan.
33.663.
663, right? Okay, degree. I can leave it at 6. Now I am not yet done because direction was taken from the vertical, and this is what? Horizontal, right? So see the angle that I need to be able to get my true direction. So what I'm going to do, I'm going to say 90 minus 33.60. So when you subtract, what do you have? What do we have?
56.34.
If you look at it based on the angle, we're going to see that this is north and this is what? East. So the direction becomes north 66 point what? Point what? 37. 3 what?
34.
34 degrees east. So this is the direction.
56, not 66.
56.
Yes.
Okay. 56.34 degrees what? 34 degrees east, not north. Okay. In a direction, you must state whether it's going east, west, or what? South.
How do you know if it's going east?
How do you know if it's going where?
East, west, north.
This is the right angle. Right angle is- if I give you an angle going this side, this is north. This is south. The essence of teaching this is for you to know if you have a resultant of more than 2 vectors, the one that you have like this, like that. So at the end, they're still going to use right angle to find the resultant vector at the end of the day. And that's what I'm going to teach you when I meet you again. Is that correct?
Yes.
Yes.
It's
When I hear necessary, get the other one.
Oyema,
Present.
Chukwucha, Nduka,
Present.
Veronica,
Present.
Semi Goma, West, Obiju, Odogu. It is not of light. Yeah, Beleme, Amojo, present. Kamsi, well, light. Ekini, Mata, Abuchi, Abigail, Lauren, Faith, Jump, all the people.
No noise.
No noise, please. That's the shade. After Chidera. We hear you, then you can go.
Okay.
I think we get you like. Okay, Michelle.
And I came for lessons. And look at me, I came for lessons. I came Yes, so this is my school. See, remember me. I came for lessons. I came. See myself. I see you. I came for lessons. I came for
I'll see you next time.
Yes. Our live stream now.
This is the right angle. This is the right angle triangle. So I'm looking for this one.
Let's just use it. We can do it.
Class.
So we can still have our normal time and still have
After you
only your time. What's with you? As a song, you're
all right, I'll take it.
This is our class. No matter what
You have to find the direction still.
If we use this portion of this, we don't need to find for direction. We need to find direction, but we don't need to say 90.
Okay, use the normal
Anyone with
arrow
stand,
to
we need to result and use the direction. Why we are doing that? This direction for the horizontal. You cannot take direction from the vertical, just take it from vertical. Get this one here. But if you do this one, try and just do 90.
Where you smile? Yes, it is there.
And thank you.
How are you? Okay, someone should clean the board. Out of your friends, are they aware you're having class? Are they aware we're having class? Where are you going to class? Are you going to the... Yes. Go and tell them they should come here fast. When you see the course, make sure you report back to me. Question by question.
This is still
How are you? What's that your name? Hey, Chukuma, Chukuma is the one who has not seen for a very long time. Ask them, they know the
I used to ask.
Who did you ask?
I usually used to ask for them.
me.
Yeah, they always ask me.
Didn't I tell you 120?
He told me that's why I came today.
It's that time, it's not your access time.
Same.
Cinderella.
Just call me.
I don't need noise. I know. Who has calculator? Yes? How are you? Started. She there's one calculator here. See, there's nothing. Juice. How are you? Prominent. They brought it.
All this is like tree that you think.
So that's
All right, so we are going to start with what we have done so far, right?
Yes.
Now we have done what and what and what and what. Right. Starting from the first topic, we're going to look at measurement, right?
Yes.
Okay, so under measurement, what are the things we should consider under measurement? Measurement of physical what?
Quantities.
Right?
Yes.
And physical quantities are quantities that we can see with our physical what?
Eyes.
Eyes. Now we see that physical quantities are divided into how many?
Two.
They are what?
Fundamental and derived
You
quantities.
still remember them?
Yes.
What are fundamental quantities?
Fundamental quantities are quantities that are independent on others.
They are the basic.
Is that all you can say about fundamental quantities?
They are the basic quantities.
They are the what?
Basic quantities.
Upon which other quantities depend
Depend
on.
on.
All right, so we can say that fundamental quantities are the basic quantities which are independent of other what? Quantities. Otherwise, or other quantities depend on what? On them, right?
Yes.
Okay, so we have the examples. Can you give me examples?
Length, mass,
time,
current,
electric current.
electron.
Now, some of you used to interchange these things when you're asked these examples of fundamental quantities. Instead of me to state the quantity, we're going to start stating the unit. It's not the same. Quantities differ from what? Units, right?
Yes.
Problems. You understand what I just said? Quantities. Fundamental quantities. There's a particular question, a past question that the students gave me the other time that I solved some problems. Do you have anyone here? Any past question? Units. So when next are coming, come with it. Okay. Now the first fundamental quantity is what?
Length.
And the unit is what? Meter M, right?
Yes.
The second one is what?
Mass.
And the unit is what?
Kg.
And the unit is what?
Kg.
Next one is what?
Time.
The unit is what?
Seconds.
Next one is what?
Electric current.
Unit is what?
Ampere.
Next one is what?
Temperature.
Temperature.
Kelvin.
Unit is what?
Kelvin.
Next one is what?
Amount of substance.
Unit is what?
Mole.
Next,
Intensity.
luminous.
Intensity.
Luminous intensity. Unit is what?
Candela.
This is not writing, they are abbreviations. Okay? They are the what? You can see in a question, which of the following is a fundamental unit? These are the units. You see meter, kilograms, seconds, amperes, Kelvin, mole, and candela, right?
Yes.
So you should know them. If you ask, these are examples of fundamental quantities. These are quantities and not what? Units. These are what? Out of these three fundamental quantities, they are out of these seven fundamental quantities. They are the three that are very important, right?
Yes.
And they are what?
Length, mass, and time.
You know why they are important?
Yes.
Use them to get the dimension of physical words to derive quantities. Did you see anybody in class?
I see they are coming. I'm not saying anybody.
How do you know they are coming?
I saw some people coming on the screen.
Okay. Are we done writing?
Yes.
All right. Yes. Derive quantities. Okay, and they are what?
Yes.
You're not going to do derivation this time. Because by now you should know their units, right?
Yes.
I believe I told you to revise the 5 examples of derived quantities, right?
Yes.
The first one we did was what?
Area.
Of area is what?
M squared.
Followed by what?
Volume.
What's the unit?
Meter cube.
Followed by what?
Speed.
What's the unit?
Meter per second.
Followed by what?
Velocity. Meter per second.
Okay.
Acceleration.
Okay.
Meter per second squared.
Mark, are you reading from your notes?
No.
Are you sure?
Yes.
By now you might have memorized all these things, right?
Yes.
Faiza, together.
Yes, ma'am.
Okay. So what's the unit?
Meter per second squared.
Okay.
Force.
What's the unit?
Kilogram meter per second squared.
Kilogram meter per second square. Okay. What else?
Work.
Okay. Okay.
Kilogram. No, kilogram
per
second squared.
Wow, that's good. What next? Pressure. Okay.
Kilogram per meter per second square.
I will buy your grapes. Look, come and look for me. I'll buy your what? I'll buy your listen tomorrow. I don't.
Yeah, let's just say it.
Okay.
Yes.
Oh, they say network is bad. We'll have to proceed. All right. Do we still have another one?
Stress.
Stress. Stress. Okay. Stress is the same thing as pressure.
Yes. Just divided by area.
Upstress is the same thing as what? Force
Impulse.
is the same thing as what?
What about area?
Upstress is weight. Same thing as force. Same thing as force. Upstress is weight. And weight and force is the same. So weight, upstress have the same unit. So if you are asked to state, if you know that these are the same, you can use the same unit. Do you understand me? Are we following?
Yes.
Your friends, are they coming? You don't know. Okay. So put it down. If you want to put it down, let's proceed. Are we done? Okay. So should I clean? What's your name? Vida. Vida who? Ekemini. Okay. I'm looking for Eke. Is it Chidera? Is it Abiku? Yeah. Yes.
Let's just see how.
See, yeah, still there. You can see it. Okay, the next thing I'm going to do is to look at dimension. Very important. Dimension. Dimension of physical quantities. Now I said earlier that we use the three main fundamental quantities to get the dimension, right?
Yes.
And they are what? I said, why are they important?
Because they help us to get the definition of dimension.
Because we use them to get the dimension of physical what?
Physical
Quantities. So my length of length is meter, right?
Yes.
When you want to write the dimension, you're going to write capital what?
M.
Okay. Then mass. Unit of mass is what?
Kilogram.
The dimension is capital what?
M.
Then what again? Time. Unit of time is what?
Seconds.
Dimension is capital what?
T.
Do you understand?
Yes.
So we are going to be looking at the dimension of other quantities. Okay.
Yes.
So if you are asked, what is the dimension of force? The first thing you are going to write is to state the unit of what?
Force.
Mercy, are you with us? Set the unit of force. That force is what?
Kilogram meter per second square.
Okay. Now how can you write the dimension?
M.
Kilogram is for mass, and we're going to write capital what?
M.
Okay. Meter is for length, we're going to write capital what?
M.
Seconds is for time, we're going to write capital what?
T.
Let's say for -2. Is that okay?
Yes.
All right, copy. There's something I want to show you now. Copy fast.
Okay.
Yes.
You said duration of store quantities. Does it need another ones? You cannot use them.
We use these three ones for dimension. Just over 3. It's suffering. Okay, done. Now, what if you're asked to derive the dimension of pressure? Are we listening?
Yes.
What if you're asked to derive the dimension of what? Pressure. If you are to derive it, you're going to start from the definition and get the unit and not get the what? Dimension. So let me just teach you one part, okay? So pressure. Pressure is force over area. Okay? If pressure is force over area, you should know what is what? Force. You should know what is what? Force. What is force? Force is mass times what?
Acceleration.
Mass multiplied by what? Then divided by what? Okay? We go again. What's the unit of mass? Kilogram. Okay, multiplied by unit of acceleration is what?
Meter per second square.
Meter per second square, right?
Yes.
Divided by area is what? Meter square, right?
Yes.
If I come here, if I bring it, I'm going to have kilogram meter per second is in the denominator, and we caliper unit like this. I'm going to carry it up, and it's going to have a negative sign when it's coming up. Because let's assume this is indices. If I have A over B, the same thing as saying AB minus what? 1. This is the denominator, right?
Yes.
And that invisible power of what? 1. I'm going to carry a negative sign. So that's what is going to happen here. Do you understand?
Yes.
So this is going to be what? Multiplied by m minus what? 2. Now from the law of indices, the bases are the same. I have meter here and minus 1 here, right?
Yes.
So I'm going to bring them together by saying this is kilogram m 1 minus 2. I'm working on the powers then. X minus 2, right?
Yes.
It should give rise to kilogram m minus 1 and x minus 2. So that is kilogram per meter per second square. That's the unit of pressure. In case they ask to derive it, these are going to derive it for them. Then for you to now state the dimension, this is what? M, right? L minus 1 and T power minus 2. Do we understand?
Yes, ma'am.
All right. Are we done? Copy fast. We are done.
Yes.
So I'm going to look at Vernier caliper and what? Micrometer screw gauge. Vernier caliper. The first thing they will ask you is, what do we use this instrument to measure? You still remember them? This to measure smaller. Example, in a question, I don't say where it's measure smaller length. No. They will ask you the thickness of a meter rule is used. Which instrument can we use to measure the thickness of a meter rule? You will now write Vernier caliper, meter rule, micrometer screw gauge. Okay? So for the sake of that, just write this instrument can be used to measure the thickness of meter rule. The internal and external diameter of a tube diameter of a rod. Now, these are the things we can use this instrument to measure. The thickness of a meter rule, the internal and external diameter of a tube, and also what? The diameter of a rod. Okay? We should also know that this instrument has two scales, right?
Yes.
It has
Main scale
and what?
Vernier scale.
Main scale and what?
Vernier scale.
Okay. Vernier scale has just how many calibration? 10 calibration, right?
Yes.
Right?
Yes.
And the reading accuracy of Vernier's caliper is classified under Vernier scale. And the reading accuracy is what? 0.01 centimeters. Right?
Yes.
Okay, so copy fast. Let me sketch the diagram. Let's read it and move forward. start fast and come up with the quality side. Are we done? Are we done? Copy fast, copy fast. Please, someone should clean the board if they are done. All right, so we have this diagram. This is a portion of what? This is a portion of what? Vernier caliper. Portion of what?
Vernier caliper.
Okay, so we have. This is my line. Is one straight. All right. So we have the portion of this Vernier caliper on the board. We are asked to read what we have there. Can we do that?
Yes.
Now, the first thing that will come to our mind is to note that this up part of this diagram is what is said to be the main scale. So this is what?
Main scale.
Main scale, right?
Yes.
Why this is what?
Vernier scale.
Now, how can we read it? Remember, this portion is where reading took place or measurement took place. Because the instrument, once you open it, you can measure the external and internal diameter of a tube and diameter of a rod, right?
Yes.
Now, once measurement is done within this point, so you're going to have this to read. So our concentration is to read it and state what you have. So the first thing you're going to read is what? Main scale. And main scale starts from here to here, right?
Yes.
While this portion is just the Vernier scale. Now, for us to read the main scale, we are going to read what is here to this point. Okay? We are going to read until we get to this point that connects the main scale and the Vernier scale. Whatever say we have here becomes our reading. Do you get me? So we are going to read from here. If this is 8, this should be what? This should be 7.9, right? This will be 8.1. This is 8.2. Now, after 8.2, we saw what? The Vernier scale. We saw what?
Vernier scale.
So main scale is equal to 8.20 centimeter. Do you understand?
Yes.
So what do we do next? We are going to read the Vernier scale, but we are not going to read this first one. It is this one that connects the main scale and the what? Vernier scale. So what you're going to do, you're going to read from here, leaving this line, right? Now, excluding this, right?
Yes.
We'll read here until we get to a point
line.
Do we understand?
Yes.
So I'm going to keep reading it until you get your point whereby the main scale and Vernier scale as if it's a straight line. So let's go. 1,
1,
2,
2, 3, 4, 5, 6, 7, 8, 9.
On this ninth one, as if it's a straight line between what? Main scale and what? Vernier scale. Is that okay?
Yes.
All right. So we're going to say that Vernier scale is equal to what?
9.
Is equal to what?
0.0.
Is equals to 9. They are going to multiply by the reading accuracy, which is what?
0.01 centimeter.
Right? It's going to give me what?
0.09 centimeter.
Do we understand?
Yes.
Then we are going to add 8.20 plus what? 0.09 centimeter. So what do you have?
8.29 centimeter.
Do we understand?
Yes.
Any confusion? Mercy. Please help her. Copy fast. Are we done? Copy fast. Yes.
That means why do you write 8.20?
Okay. Whenever you are reading this Vernier caliper, anytime you see this line, the last line before this will be the end of the reading of the main scale. Because it is this line that connects the main scale and the Vernier scale. So I'm going to read until we get to this point. What if this line will end? What if this line is here? We are going to end at this line. Do you understand? So this is the line that ends the main scale reading. And the line that connects the main scale with the what? Vernier scale. That's why we end at 20. Okay. Yes.
No, when you the Vernier scale, for instance, now if it's not at 9 and it's 4, 5, the one line 4, 5 join together, how will you start counting?
It's before 5.
Yes,
That is here.
yes, and they are joined together. How
Yes,
will
now it will be 8.24. Yes.
you put down anything to do with what's given?
Now, when you are counting this now, you are looking at up and down where this line meets at a point. If it connects here, that is already. If it connects here, that is already. You're going to pick that line. As you're counting it, you're going to pick this line here. Once it connects, you end there. That's when the up and the down combine together to be a straight line. Okay? That is your reading. Is that clear? Now, can we go to micrometer screw gauge?
Yes.
All right. The other. Is it clear? All right. Micrometer screw gauge. Done. Okay, so you know what we use this instrument to do? Micrometer screw gauge. Wendy. It's not Wendy. Yeah, no, it's disturbing me. Micrometer screw gauge measures in what? Milli. This is to measure very, very small things like what? Example. Thickness of what?
Thickness of a textbook. Thickness of a piece of a paper.
Thickness of a piece of what?
A paper.
Please put it down. That's what they're going to ask you. The thickness of a piece of paper can be measured with an instrument called dash. They will give you Vernier caliper, meter rule, tape rule, micrometer screw gauge. So write what we can use this instrument to measure. Micrometer, screw gauge. Okay? You can use them to measure the thickness of a piece of paper, the diameter of a wire, and what? Diameter of a small bulb. And then the radio accuracy is what?
0.0
Millimeter or
0.0
okay. But most times we measure it in what?
millimeter.
We're going to be using 0.01 what? Is that clear? All right. Yes, what's the question?
So if they give us our distance in centimeter, we should measure it by 0.001.
If they give you what?
Maybe the distance we should measure it to 0.001 micrometer screw gauge.
Now after that, I'm going to ask you a question to see if you can be able to solve it. Yes. Why?
Why is the solution
What we used to measure. After the what we use it to measure.
Anyway, it's the solution.
Now worry, I don't understand your question. That is how the diagram, that is how the instrument is. What I showed you for the instrument before. Alright, this is the main scale. This is my math, I don't understand today. And this right? Now for the main scale, I'm going to read. This is 0, right?
Yes.
1, 2, 3, 4,
5.
6,
7.
After 7, we'll start this line, right?
Yes.
And this is the line that connects the main scale and the vernier scale, right?
Yes.
Automatically, the reading of the main scale is going to end there, right?
Yes.
So main scale millimeter. Is that clear?
Yes.
Is that clear?
Yes. I think no. What about that one that's under the 0?
This one,
No, that the line that.
this one.
Yes.
Okay, let me remove it. Any question?
Yes.
What's the question? We are counting the line from here. This is 0 for the main scale. This is the line that connects the main scale and the vernier scale. So once you get to it, you're going to end. I got it at 7.00 millimeters. Okay. So the next thing we are going to do is to count the what?
Vernier scale.
The vernier That is this line, right?
Yes.
That connects the main scale and what?
Yes.
We are going to say that this is what? Multiply the 50 by the reading what? Accuracy, which is what?
0.01.
So what do we have? 0.50 millimeters, right?
Yes.
So we're going to add the reading of the Vernier scale and what? Main scale. That is 7.00 millimeters plus 0.50 millimeters. What are we going to get?
7.50.
Do we understand?
Yes.
Confused. Who is confused? Now a situation whereby you have something in between here. You know what it means? 0.5. If this is 0, 0.5, 1, 1.5, 2, 2.5, do you understand?
Yes.
So if your Vernier caliper has a calibration and it is inside this way, you're going to add in what? 0.5. Do you understand?
Yes.
I'm going to give you classwork.
Yes, ma'am.
Sketch a Vernier caliper reading 6.29 centimeter. Sketch a Vernier caliper reading 6.29 centimeters. You know what I mean? You're going to sketch it and it's going to read this. So I want you to try it. Let me see what you can do. Get to work.
Yes, are we done?
Yes.
So let me just give you something like this. So in case you see it in the exam, so you not be like, what is this? What is this? What is this? Yes, now. Just like you learn hard things. So when you see it in the exam, it's like, it's very simple. Exam is very simple. It's time for your dining, right? Yeah, done. So who will do it for us on the board? Prominent, come. Come and solve for us. Let's see if you are correct. I've not seen your work, oh. Eh? Take matter there, clean the board. Who's the other one? Take this one. I don't. What happens to the long line there? On the main scale. Is she correct? Is she correct? Is she correct? Who correct her? Don't correct her. Is she correct? Is she correct? Correct? Is she correct? Yes? She's correct. She'll give it to her. No, she's correct.
Yes.
Are you sure? Like very sure.
Just the ups.
Oh yeah, go and draw the upside very well. Give her. One, two, three, four. Why is the line still down? Take it off now. Eh? 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. This will not be what? This is centimeter, okay? Is she correct now? Just that you have to increase the main scale up, right?
Yes.
Don't write it small, 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 as if you're afraid of the line. All right, people have done well. Yes? If you join the
Perhaps in our question, the bigger scale. The line, that line element at the bigger scale is joined the bigger scale. It's joined the bigger scale.
come and show me.
If this line is joined with this one, because it's joined with this one, yes. You can't, you stop here. Where this line is. What's that?
Yes. See, join here. You now count it. Where is Amanda? Ella? Okolo? Mamadu? Chikeze? Rosemary? Chinda? Ifetu? Chinagoro? Aleke? Kewe? Ifes? Ogechi was Sophia? Finesta? Mercy? Chimene? Jessica? Estienne? Boniface? Nawario? Ike Marvelous? Chooks? Ohaka?
Present.
From Promise?
Right.
From Success? Onugwe? She's not back.
Yes.
Faiza?
Present.
Yala?
Present.
Who? Wendy? Muna? Babatunde? Yesterday. Ikechi? Dick? Jauda? Ekemini? I want to be seeing your face. So, Ibinabo? Irisonga? She came yesterday, right?
Yes.
Wendy Favor? Nebo? Amos? Who did I hear name? What's her name? Eh? Tell me. Why? I've seen this face several in my class. So why is her name not here? Eh? Okay, well, let's pardon them for this thing. Next thing. Continue. All right, I'm going to see you. When next are we meeting again? Is it they have one single paper?
Yes.
Which day?
On Friday.
On Friday.
Yes.
We have one single paper.
Yes.
So we're going to meet Friday,
Saturday, Sunday.
is that correct?
The same time.
Same Friday will be that.
After that.
Let's meet by 4. Okay? All right.
Wow.
For your listening, let me settle you now.
Bye.
Show your face. I see. Come come back. Show your face. Shift it. Yeah, shift it. Why is that? Why is that? That's the fault.
Who carry the trauma head?
Yes. Leave them. I said she leave them. Go for dining. I said.
Somebody's calling you.
All right. Now we want to look at the unit of G. What is G? G is gravitational constant. If you're able to get the unit of G, we can as well get the dimension of G. So how do we do that? We are going to make it the subject, okay? This formula was gotten from the law of universal gravitation, okay? Which says that every particle in the universe attracts every other particle with a force that is proportional to the product of the masses and inversely proportional to the square of the distance separating them, okay? So with that being said, we generated this equation, which is F equals gm1m2 over r squared. Now I want to make the units, make G the subject of the formula and as well as get the dimension of G. So how can we do that? We can do that by saying this is over 1 cross what? Multiply, okay? So gm1 m2 multiplied by 1 is going to give me to get this, the next thing I'm going to do is to find the unit of what? Force. Unit of force is what? The unit of force is Newton, and this is what? Radius, which is measured in meters. We can decide to leave Newton because we want to get the dimension, but have a negative sign. So unit of G is equal to what? Kilogram meter per second square multiplied by meter square, then multiplied by per kilogram square. Right? Now what do we do? This one have a power of 1. Now this is power of 2. Let's add it together. This is kilogram 1 minus 2 meter 1 2 per kilogram meter cube per second square. So this is the unit of gravitational constant G, okay? Now for us to get the dimension of G, of G is equals to kilogram per meter, sorry, per kilogram meter cube per second square. Now, how do we get the dimension? Dimension becomes what? This is m power minus 1, l power 3, and t power what? Minus 2. So this is how we can get the dimension of universal gravitation. Universal gravitation, okay? This is how we can get the dimension of universal constant, which is what? G. Is that okay? All right, so I've come to the end of today's revision. Next time in the next one. Bye for now. Bye. All right. All right. So the last time what we did was trying to do construction by concave mirror. Right? Yes. Who was my class yesterday? One day on, one day off. One day on, one day off, right? On and off. All right. I don't need that. What is the other line? If you're going to see meter read, whether it's short one, let me and do this. All right, so I was able to explain some certain facts of the pole, which is the midpoint of the mirror, the aperture, which is the width of the mirror, then the center of curvature, the radius of curvature, the principal focus, the focal length. So we're going to be looking at the positions of various objects. Positions of objects to form the image point. What is P? Pole. Know what is F? Principal focus. So we have two types of mirrors: concave mirror and what? Convex mirror. That is inside. Guys, this is the reflective surface for a concave what? Mirror. For convex mirror, the reflective surface is what? Outside. So I said also that irrespective of where the object is placed in a convex mirror, that the nature of the image remains. Now, this is a concave mirror. This is my marker. Go help me. All right. Now this is what? This is the pole. Using 2 centimeter, we are going to use 2 centimeter from here to 2 centimeter, but I'm going to use 20 centimeter here, right? But in your own, you're going to be using what?
2 centimeter.
So from here to here, 20, right? You know to the point, then here will be what? 40, right? Now, this is what? Center of curvature, right? Now, then the object is placed between F and what? P. Then if the object is between F and P, that means we have this to be 20. Half of 20 is what?
10.
I'm going to put or place an object at what? 10. So let me look at the height of the object. Can I use the height of the object to be 10? Let me see. That means this is the object. Maybe the height of the object to be what? 10. Then I told you, I gave you the facts we are going to be using. What's the first one? Can you read it?
If
Maybe one person was in class yesterday. Okay, so read it.
which one?
Number one, the first one.
Those three facts.
Yes, let's start with number first one.
Away from the object which is parallel and close to the principal axis, this through the principal focus after reflection.
Now, a ray from what? The object. Look at the object. Okay, so this is the principal axis. The line that passes through the P and what center of curvature, right? Now, a ray, any ray that is parallel to this, then the ray will be going in the same direction with this. Okay, once it touches this object, as soon as it touches this concave mirror, it's going to do what? Reflect and pass through where? The principal focus. Right?
Yes.
Okay, so let's try it. This is scared. This is the ray, right?
Yes.
Okay. Can you see that?
Yes, ma'am.
This is the ray. Now we need an arrow to show that the ray is going towards what? To the mirror. And because it's a mirror, there must be a reflection. And once it reflects, it's going to pass through the principal what? Focus. That is what the rule is trying to tell us. Now, any ray that passes a move and passes through the principal focus. So these are that my line. The marker is not that well. Can you see what I just drew?
Yes.
That's what the first law is saying, and it's going to remain constant. Okay. Any ray from the object, that means the ray must touch what? The head of the object, right? And it is parallel to the principal axis. This is the principal axis, this line. Okay. Now, once it touches the reflecting, so what does number 2 say?
A ray from the object which passes through the center of curvature is reflected back along the same path.
Okay, center of curvature, right? Anywhere that from this center of curvature and touches the object, once it reaches here, it's going to return back along the same path. That's what you're trying to say. So remember that we need this arrow to show you that going in or coming out. So this is incident, right? This is reflected, right?
Yes, ma'am.
Okay, so we're going to do our sketch. This ray will pass through where? Okay.
Yes.
All right, so let's go. Did you see it?
Yes.
It will go and do what? Return along the same path. Now, look at the two reflected rays. Reflected ray is what that is pointing out, right?
Yes.
This is a reflected ray. This is a reflected ray. If I extend it on, they are going to meet.
No.
Let me extend this one. Is there a possibility of them meeting each other?
No.
They can meet, right?
Yes.
Can they meet?
No.
They cannot meet. So if they cannot meet, this is the front of the mirror. Why this is what?
The back.
If the reflected ray did not meet in front of the mirror, there's a possibility they are going to meet where? At the back. So we are going to extend it to see where they are going to meet. But if they are extending it, we are going to use a dotted what?
Line.
All right. To show you that this is not a any image that is formed here, if the two rays intersect, that forms image. But if they do not intersect, we are going to check where? At the back. All right. Any image that is formed in front becomes real. Anyone that's intersected becomes what? Virtual. Even when you are solving mathematics as well, you're still going to get it as what? Virtual. Do you understand?
Yes, ma'am.
Okay. So we go. We extend this line. With a dotted line. Extend this one a dotted line. Can you see it now?
Yes, ma'am.
Now they made right. Okay, let me extend this. Right? Now what can you say? Let us join the point. This becomes image. This becomes my what? Image. What can you say about the image? Let's go. Image is what? Yes?
Virtual.
Virtual. That is the first thing because it did not form where, it did not intercept where in front. It intercept where? So it is what?
Virtual.
What again can you say? What again can you say? Is it not pointing up?
It points upwards.
The image is what?
Erect.
It's either use the word erect or use what? Okay. Now look at the height of the image and height of the other. Which one is bigger?
Height of image.
We can say that image is what? Magnified. You're looking at the book, right? That's right. These are the terms we use. We don't use bigger. Okay. Now we have one more thing to say. Behind the mirror. Look at the mirror. It's behind it. Do you understand?
Yes.
So using this measurement, you can get it accurately. That's how I use measurement. I'm using this and I use 20, 20, right? So from here to here is what? 40. Between P and what? F. I'm going to place it at what? 10. Right? And I gave the height of the image to be what? 10 centimeter. Do you understand?
Yes.
All right. Yes.
So if those two lines now intersected,
No. If it met in front, maybe it will be formed between F and C or form as C. You also tell us where it formed.
Auntie,
You know
does
that
the
behind
C, does it have any measurements?
Yes, no. It's from here to here. We are not using measurement to do anything here. It's just for you to have a fixed measurement that you're working with.
I thought it's from this point to F that is 20.
I just use that to be 20. I want to have a fixed measurement so I can have an accurate construction. In construction, you need to have a measurement, okay? So that throughout the whatever thing you are doing, you're going to see that it's going to come out the way it's supposed to be.
From F to C is 22.
From here to here, 20, from here, 20. But we're using this in your book. You're going to use 2, right? Height as what? 1. You're going to get the same thing as what I told you. Is that clear?
so we should not draw it since we're not using it.
Draw it fast, do a rough sketch. All right, I'm going to do the second one, or I can do the third one, just for you to see how it is done. That was less common.
No.
Should you go around on your head? Yes, that's your dream. Oh yeah. Design it on your head. Fast. Fast. Your face will show it.
She did have she.
But you also want to just did.
Yes.
Showers.
Sorry, no.
I want us to do another construction. Now, there's something I want you to know. See where the object is placed. So in the question, we'll be asking you that the image object distance is 10 cm. That means from here to here, they're giving you what? That is in the question. You have to find the image what? Distance. Okay? All right. And the distance from here to here is radius of curvature. Right?
Yes.
What I explained yesterday. And distance from here to here is focal length. Is it principal focus? This is focal length. So we now agree that this is equal to r over what? 2. Right? From yesterday's class. If you are done, I want to clear and do the next one. So I will understand how to do it then. Done? Alright, so let's move to the next one. Let me just clean this one up. Are you saying the same? Now, the object will be at where? Principal focus, right? Yes. Are we following? Yes. Is at F. Remember, we did between P and F. Now we're going to do at F. After F, it will be between F and what? C. And next will be at what? C. And there's something I want to teach you, which is a jam question. The way jam will ask you is what you know, but they'll just change it. They'll ask you, where are you going to place an object so that the duplicating machine will give you the same thing as the object. I'm going to get this from this from here. You have not been going through your jam question.
Yeah, we have.
You are going to see this question. Check it in. Can you use the Pro50? Check it in under reflection, curve mirrors. What's that? I don't want that sound. Now, let's take our measurement. From here to here, we did previously to be 20, right? Yes. So I'm going to note this 20 and this 40. Okay? So this is C. Where am I placing the objects? At where? F. And the height of the object is taken to be what? 10. Okay. This is O as the object. Now, you are still going to use the rules again. Read the first one.
Area from the object which is parallel and close to the principal axis passes through the principal focus after reflection.
Now, this is the principal axis, right? Anywhere that is parallel to this and that will pass through the object is going to reflect and pass through the principal focus, right?
Yes.
All right, so okay, so this is the ray, right?
Yes.
It will pass through the principal focus. Did you see it? Root.
Area from the object which passes through the center of curvature is reflected back along the same path.
Okay. So look at it. Now look at it. This one is going back, right?
Yes.
Now the problem is, look at it. Do you think they are going to meet at the back?
No.
Do you think they are going to meet at the back?
No.
But from our say it's going to meet here. Is there a possibility of them meeting? Hmm? But the image is real and it's inverted. So what happened? Let's extend it and see whether there's a possibility of them meeting, okay? By extending this, is it possible?
No.
Are you sure?
It's possible in my book.
It's possible. It's possible. It's possible. Well, you can try it. It's possible. It's possible.
Mine actually.
What are you drawing?
Of sketch.
It's possible. All right, let's see. Let's see whether it's from here. That is why I said we should use measurement, because if you make any single mistake and alter, no mistake, Abby. But it's going to miss in front. That is just the truth. So what you're going to do, when you want to measure your own, you use 2 centimeters. Okay. I taught my students and it's joined. Yes, but it's very far. They have to join another book here and keep extending for it to meet. Do you understand? So you're going to try it, it's going to join. The image is what? It's real. Image is real. And any real image must be what? Any virtual image must be what? Upright. Any virtual image must be what?
Upright.
Any real image must be what?
Inverted.
So this is inverted. And also, it is magnified because it is bigger than the object.
And it's in front of them.
Yes, but it is beyond C. What did you write in your book? Infinite. Very far. That says you cannot see it here. They have to extend like 2 full scarf before they saw the image.
So I think tell us to do something.
They will give you the one that you can see in your book. But see, if you are drawing anything, you see them doing like this, as in narrowing to each other. That means they're going to meet very fast. So you take it as real. Do you understand? Take it as real. So it's at what? Infinity. I don't know if you understand.
Yes.
All right. So you're going to do the next 3 as your assignments. As I do this, you're learning. Okay? The one I want to do now is image formed by a convex mirror. It has just one nature of the image form, irrespective of where the object is placed. So your assignment, are we done sketching?
Yes.
Yeah, still sketching. The assignment that's number 1. when the object is between F and C, object at C beyond C. Beyond C means 10 cm from this. Place the object that is beyond C. Then like when the object is at C, okay? When the object is at C, the first and the second will not work. The second will not work. So I'm going to use the first and the third. So let me just do that one. You understand? When the object is at C, the first and the second rule will not work. The second will not work. You're going to use the first and the third to form an image. Yes. Are we done now? Yes. Bell. Ifed, are you done? What happens to Eniola, Fury, and the rest? They don't know the time yet. Recovery. From where? Or she came for chemistry. She's not recovered from it. I thought those people in the
Class to tell
them.
How do people know that?
All right. All right. Can we proceed?
Yes.
What to do when the object is at C? The essence of me drawing this is that when I start solving problems, you'll be able to have an understanding. This is where the object is placed. This object distance from here to here, right? Now, when you get your image distance. See the height of the object. That is where magnification will set in. Okay? All right. No noise.
And this one is it when the object is beyond C.
Now, what to do when the object is at C? I want to teach you something. Don't forget your measurement, okay? That is very, very important. So from here to here, 20, 40, right? I'm placing this is my what? F, and this is my what? C. So I'm placing the object at where? C. At C. And the height of the object is what? I'm using 10. We're going to use the first rule and see if the second one will be feasible. If it's not feasible, let's use the third one. Can we proceed? Yes. So what's the first rule? By now it should be in your brain, yes?
Yes.
Yes.
A ray from the object which is parallel and close to the principal axis passes through the principal focus
After reflection, right? Yes. Okay. Pay attention. Now look at it. Right? Now, what's the second one?
center of curvature is reflected back along the center.
Now where is the center of curvature?
Center.
Can it work?
No.
There's no way the ray will pass here and still reach here. So that is why the second one will not work. I told you, right?
Yes.
So let's look at the third one.
The ray from the object which passes through the reflected
focus is reflected parallel to the principal axis.
Now, any ray that passes through this object and touch the principal focus is going to reflect parallel axis. So let's go. I don't know why I'm not up to date. It's not really right. No noise. Now look at it now. And if I extend this, now if all is going in and this is coming out, right? Now, where did they see the one that will intercept is the reflected ray. See the reflected ray, this one. See the reflected ray, this one. They are going to meet here, right?
Yes.
So if they meet here, I have a small slight difference. It's supposed to be here because the image is the same size as the object. So I wouldn't know where the error is coming from. Okay? I don't know whether it's from this my marker that is giving me slight difference because I'm trying to make it clear. It's supposed to be. So when you are sketching your own, I've given you a clip. When you are sketching yours, you should know the image will be here, the same size as the what? Object. So if you are asked, what's the image? Image is what? Image is real because it is in front. Say image is real. Okay, and what again? Inverted. And what again?
Same size as object.
Same as object
It is at C.
at C. Now, this is the only point where when you place a paper on a duplicating machine, it's going to give you the same thing as the object. That is at the center of what? Curvature. That is what the JAM question asks. You are going to place the object at the center of curvature to be able to get the same thing as what? As the image. All right, do you understand?
Yes.
Any question? Any question? So let me do that of a convex mirror. I'm going to do one, and it's just one. See, this concave has different positions of an object, okay, with different nature of the image form. But for a convex mirror, anywhere you place the object, the image remains what? The same. That's why we have just one diagram for convex mirror. And I'm always like asking you that. The image formed by a convex mirror is dash. They'll tell you diminish, upright, and virtual. Has these three properties. Always comes out in exam. So can we go? What is the difference between a concave mirror and a convex mirror?
The convex mirror, the reflecting part is the outside surface. While concave,
The reflecting part is outside.
All right, so let's do the next one. Which is this. Right? Now for a convex mirror, this is the back of the mirror. Okay? Why this side is what? The reflecting surface. So let us draw our principal axis. All right. So let's do our measurements. Remember, I used 20, right? 20 here. This is my principal focus this way, and I will do 20 here. All right. So, and this C. What we have, we are going to use the same rule. Let us place the object. We can decide to place it as F, or we place it between P and what? F. Let's see what the image is going to give us. We are placing it between P and F. That means that we're going to place it at 10. And the height of this is what? So can we read the first rule?
A ray from an object which is parallel and close to the principal axis passes through the principal focus after reflection.
Okay. Now this one, because it's a converging mirror, it's going to do what? It's a diverging mirror, so you're going to do what? It's going to do what? Scatter. It's going to do what?
Scatter.
All right. So on coming here, this is now. It's going to scatter. Now we're going to extend it where? To this point. It's supposed to meet at the focus, principal focus. Okay, let's proceed. Let's proceed. Let's try this now. Okay, proceed. What's the next one? What's the next one?
the reflected back along the same path.
Okay, so that's the center of This one is very thick. Now, this is a ray going in and coming out. Today, I don't have block for marker today. All right, so there is an interception here. This becomes the image formed. There's an interception here. This becomes the image formed. So what can you say about the image? The image is the same throughout anywhere the object is placed, irrespective of the positions of the object. The image remains the same. Okay? The image is virtual. Aside from being virtual, it is what? It is because it's very small. Look at the image, very small. The object is bigger than it. You can even measure the height. For you to know whether it's diminished, you measure the height. You see that it's what? It's roughly 5. So it says the image is what? Diminished. Apart from being diminished, upright or erect. Upright. Upright or erect. I think what? What again? You can say behind what? Please, do you understand what I'm doing?
Yes, ma'am.
So these are the properties, or we can sketch the ray construction of a concave and convex mirror. All right, so let's go to the calculation part. Sketch, are you done? When did you finish? Where is Agnes?
There was.
Then where is come? Mbanude, where is the Jofo? Ekigwe. I didn't see her yesterday.
It was part of it. It was part of it. We went for their robotics.
Okay, Ekigwe went for robotics.
But they came back today. They came back yesterday.
All right. Can we proceed?
Yes, sir.
Mirror formula. How many subjects do you have on Tuesday? One. So immediately after afternoon, then by 4, we are having lessons. On Tuesday. Mirror formula. All right?
Yes.
One over F is equal to 1 over U plus 1 over V, right?
Yes, ma'am.
Right?
Yes.
Okay. Now, we should also know that the focal length is radius of curvature over what? 2. Right? Then magnification produced is what? Image distance over object distance, which is also equal to height of image over height of object. The same thing we applied in pinhole camera is applicable here. Is that okay?
Yes.
All right. So what is U? U is object distance. V is what? Image distance. And F is focal length. R is Radius of what? Radius of curvature. Is that okay?
Yes, ma'am.
Showers, are you with us? All right. For those of you that were not in the class yesterday, I said that once we vacate, we're going to continue with our online class. You are laughing, eh? Be laughing because I want to finish the remaining topics for my girls, indirectly for my girls. Then, once we resume January, I'm going to start with JAM revision classes. Topic by topic, that is what I said. Is that okay?
Auntie, when this was?
When we go home. By January, I'm not going to be looking at for me to or for you to get your 15 over 15 in your test. I'm not interested in that one any longer. I'm interested in what I can do outside the school to get me admission. So like I said, get your prep 50 pass question for JAM. I'll post it on the platform for you. Friends will go and buy it for you. Hey Zocha, what are you doing there? Note, for a concave mirror, the focal length is positive. For a concave mirror, the focal length is positive, and a convex mirror, the focal length is negative. And for a convex mirror, the focal length is what? Okay. And also for a concave mirror, we already know what is a concave mirror and a convex. For a concave mirror, the image distance is positive. And for a convex mirror, the image distance is what? Negative. It's positive. And for a convex mirror, the image distance is negative. All right. Can we solve? An object is placed 10 centimeters. An object is placed 10 centimeters in front of a concave mirror. An object is placed 10 centimeters in front of a concave mirror whose radius of curvature is 12 centimeters. Whose radius of curvature is what? 12 centimeters. Full stop. Done. Calculate the position. Calculate the position, nature, and magnification of the image produced. Calculate the position, nature, and magnification of the image produced. Are we there? All right. So let's solve. I'll send you out. Don't try me next time. So if an object is placed 10 cm from a concave mirror, that means the object distance u is equal to what? 10 cm, right? Then what again do we have? We have radius of curvature, right? As what?
12
So
centimeters.
our r is 12 centimeter. And for us to get the focal length, f is r over what? That is 12 over 2 to give me what?
6 centimeters.
But because it is a concave mirror, I'm going to say plus what? Do you understand? If it's a convex mirror, it's going to be negative. I told you now. For a convex, focal length is going to be what?
Plus 6.
For a convex, it's going to be what? Negative. Okay, so what are we looking for?
I'm looking for the
Position, the nature, and the magnification of the image produced, right?
yes.
So we are looking for V. Let's start with the what? V. Our formula is what? We are going to use 1 over F is equals to 1 over U plus 1 over V. Okay? Now, 1 over 6 is equals to 1 over 10, right? Plus 1 over V. I want to take this to the other side. 1 over 6 minus 1 over 10, right? Is equals to 1 over V. All right. Let me come this way. Now, can we find the LCM? It's going to give us what? Can we go with 60?
Yes.
So LCM is 60. 60 to 6 is going to give us what?
10.
10 times 1
10.
minus 6. Okay? It's equals to 1 over V, right? All right. So when you subtract, what do we have?
4 over 60.
4 over 60 is equals to 1 over V, right?
Yes.
If I say cross multiply, 4V is equals to 60, right? Divide both sides by what? 4. So what's my V? 15 centimeter, okay? Then the next thing I'm going to look at is the magnification produced. What's the magnification produced? M is equals to
V over U.
V over U, right? That is 15 over what?
15 over
10. So what do we have? 1 point what?
5.
So what can you say about the image? The image is what? The image is what? Real. Because once V is positive, the image is what? Real. The image is what?
Real.
What again can you say?
It is
Any real must be what?
inverted.
Any real image must be what?
Inverted.
What again can you say? Is it higher than, look at the image distance, it's higher than the object now. We can say it is magnified. Okay? What else can you say? What else can you say? Okay, can you do that? Or I can say form in front of the mirror. Are we done? All right. That is a jump question. Let's go. A concave mirror. A concave mirror has a radius of curvature of 36 centimeters. Am I writing? A concave mirror has a radius of curvature of 36 centimeters, right? At what distance? At what distance from the mirror? At what distance from the mirror should an object be placed? Should an object be placed to give a real image To give a real image 3 times the size of the object. Let me come again. Are we there? I'm coming. Okay, let's go. A concave mirror has a radius of curvature of 36 centimeters. Are we there?
Yes.
All right. At what distance from the mirror? There. Should an object be placed? Should an object be placed to give a real image 3 times the size of the object? To give a real image 3 times the size of the object. This is a jump question. For those preparing for jump. So let's solve. Now, what are the parameters given in this particular question?
Radius
R is given as what?
36 centimeters.
Okay, what again?
They give
Do you have focal length? You can get focal length from here.
Yes.
The focal length is equal to R over 2. That is 36 over 2. Which will give you what? 18. Okay, what again? They said at what distance should the object be placed, right?
Yes.
They're looking for you. And he gave us 3 times the size of the object, right?
Yes.
That is magnification. Once you see a statement like it becomes magnification, okay? So magnification M is equal to what? 3. And we must not forget that magnification is equal to V over what? U. Right? Are you paying attention?
Yes.
Now, you can say this is over 1, right? If I say cross multiply, V is equal to 3 what? U. We are looking for the size of the object, which is, we are looking for the object distance. Okay, so I'm going to use our formula. 1 over F is equal to 1 over U plus 1 over V, right? Right? So what's my 1 over F? 1 over 18. Okay, 1 over 18 is equal to what?
1 over
Plus 1 over 3U, right?
Yes.
Let's find the LCM. What's the LCM? What's the LCM here? He's saying 20 something. 3U, right? This interval is going to give me what? 3. 3 times 1, 3. Plus 1, right?
Yes.
I'm going to say 1 over 18 is equal to 4 over 1. Right? You can say cross multiply. 3U is equal to 4 multiplied by what? 3U is equal to what? What do we have? 4 times 18. 72, right? So 3U is equal to 72. Divide both sides by what? 3. So what's my U?
24.
24. See the kind of question jam is giving, and you don't need calculator to solve this. It depends on the question. If you're asked to find V, you can find U because V is equal to 3U, right?
Yes.
So V is equal to 3U. That is 3 times what? 24. So what do you have?
72.
72, right?
Yes.
All right. Can I give you a question to solve? I should not give you.
Give us.
It's a similar question, still jam.
How do you know if the image is formed at the back? Because for convex mirror, it's always formed at the back, and sometimes that the back has quite a line.
Now, if you are solving a problem, they will give you the question at the end of the day, you're going to get a negative sign. Using LCM, cross multiply, you're going to get a negative sign. You know that it's convex. There's some concave that the image is what? Negative vector. All right, so can we solve?
Yes.
A real image. A real image. Three times the size of an object. A real image, 3 times the size of an object, is formed 24 centimeter. Is formed 24 centimeters from a converging mirror. Where are you? Converging mirror. Full stop. What is the focal length of the mirror? A real image 3 times the size of an object is formed 24 centimeters from a converging mirror. What is the focal length of the mirror? So, Are we done? What's the answer? Eh? That does not sound like the answer. That I think does not sound like the answer.
So what's the answer?
Any other answer? No. Then what do you have?
Auntie, just tell us the answer.
Manude, what do you have?
Auntie, what is your answer?
6.
Auntie said, what's it?
Just say your word.
I got it, but it's in my head.
Now, let me give you a clue. Can you read the question? Let me explain for you.
Yes.
A real image, 3 times the size of an object, is formed 24 centimeter.
So it's okay. What did you record as that 24? V or U?
You.
A real image. Image is not V. A real image, that is V. But it is formed 3 times. That is magnification is 3. But V is 24. You mixed it up.
Okay.
From there you can get to your U, then still find your F, right?
Yes.
Okay. I've gotten the answer.
What's the answer?
6.
Alright, so this is a jump question. See how this is tricky. Yes. And you tell yourself that you got it. I know I got it. I know I got this thing. I got it.
What if, like, if it's you, right? But you know, what they gave us is you. How are they going to say? How are they going to put it? Like, this one.
The question will say it that way. This question was, they said a real image. They're talking about the image. They didn't tell you objects. So why were you using you? They said a real image. Okay, so.
Okay, Auntie.
Yes.
They say object is you.
Is you.
Image.
Now, assignment. I'll give you the answer so you can go and try. Are you ready?
Yes.
The magnification of the image of an object the magnification of the image of an object placed in front of a convex mirror. The magnification of the image of an object placed in front of a convex mirror is 1/3. Is 1/3. Full stop. Are we there?
Yes.
If the radius of curvature of the mirror is 24 centimeters, if the radius of curvature of the mirror is 24 centimeters, what is the distance between the object and its image? What is the distance between the object and its image? And its image.
The answer.
The answer, like 32 centimeters. All right. Can I take our pen down? Yeah, not yet. What? Let's all delete.
Present.
Kosi. Agiken. Is she okay?
I don't know.
I'm not saying I have a very long time.
This class was awesome. Oh my god, every like, oh my Jesus. Oh god, you just have to watch this class. Bye. Bye. Thanks for watching.
Did you know
Right. Oh my God, choke. My brain don't fool me, please, my dear. If you know what this class, you know follow.
Like and subscribe. Let's go. Don't forget to like and subscribe to this channel. Share is the best. I mean, next time this is the goal.
And don't forget, my name is Asia the Don't forget, like and subscribe.
The class was fun.
Like and subscribe.
You will never put this down.
I am good now.
As long as it's on there.
Oh, good. Jesus. My dear, she did this here.
I'm sure you like it.
Anthony Dennis, how are you? How are you? Anthony Dennis, how are you today?